Hello and welcome to the Bitcoin Mining Farm Infrastructure Fundamentals. Hi, my name is Mike and I will be your instructor for this course. With this course, you will get the fundamental knowledge of Bitcoin mining farm infrastructure. You will also know the considerations and requirements in building a Bitcoin mining farm. Lastly, you will also learn how to track metrics and make sure that your mining farm is in its most optimized state. This course is for people who wanted to own a Bitcoin mining farm, as well as people who are going to be consultants for their Bitcoin mining farm clients. This course is also for people who want to scale up their Bitcoin mining farm operation. So now let us go over the course outline for this course. We will start off with the foundation section and begin with the Bitcoin Mining 101 video. We will then move on in talking about the mining hardware basics and end this section with mining rigs and your income. After the foundation section, we are going to move on into the heart of this course, the various design considerations. So in this section, I'm going to first touch base on what kind of requirements do you need at the start of the project, what kind of things are you going to be expecting. Then we're going to look at the site in itself through the location and building requirements. And then we are going to look inside the building into looking at the facility space. Then we're going to move on to perhaps two of the most important requirements that you will be seeing when you are building your own Bitcoin mining farm facility, which is the power requirements and the cooling requirements. Next, based on the power requirement and the cooling requirement, we are going to look at how are we going to do the cabling for your Bitcoin mining farm. Lastly, we are going to touch base on the topic about security in this section. We are then going to end this course with our last section, which is reliability and metrics. In this section, we are going to look at how can we optimally organize the mining farm facility such as that it could be ready for growth. We will then look at the redundancy and availability for your mining farm so that you can actually keep it online as long as possible. Because the more times that is online and mining coins for you, the more profitable your business will be. Lastly, we are going to look at the documentation and the monitoring schemes that you should have for your Bitcoin mining farm so that you can keep track of your mining farm status and ensure that your business is performing the best that it can. So first of all, thank you for taking interest in this course. As you know, you can make your own Bitcoin. Unlike fiat currencies such as the euro or the dollar, you can mine Bitcoins even at home, whereas you can't print money or go and mine gold or silver. By default, each node that is generating Bitcoins is a part of the Bitcoin ecosystem that is focused on peer-to-peer networking. Now, you might think it is good and all that we can start mining Bitcoins, but how tough really is it to mine Bitcoins? It is actually not that complicated. A mining machine can be created by someone with any experience of using a computer and with just a tiny little research on the internet. In fact, that is what I'm here for, to bring you from a novice to building a state-of-the-art Bitcoin mining farm. Now, this course is focused on the hardware and infrastructure needed to build a state-of-the-art Bitcoin mining farm. But since I mentioned that this course is targeted for people at all levels, even for people who completely are not aware of what Bitcoin is, I would like to take the opportunity to do a brief introduction on Bitcoin mining in our Bitcoin Mining 101 video. So let's start off with our first question. What is Bitcoin? Without a central bank or single administrator, Bitcoin is a decentralized digital currency that can be sent from user to user on the peer-to-peer network without intervention from any intermediaries. Transactions are checked by cryptography by network nodes and registered in public distributed ledger. This ledger is also known as what we call the blockchain. In a blockchain, each block contains a hash of the previous block up to the chain's genesis block. The blockchain is managed by a network of interacting nodes that are running a Bitcoin software. Each transaction are broadcast to this network using this software. The network nodes will verify each transaction, add them to the ledger copy, and then broadcast it to other nodes, where each one of them stores its own copy of the blockchain. A new set of approved transactions called a block is generated at differing time intervals, averaging every 10 minutes, and published it to all nodes without needing central supervision. Bitcoins are registered to addresses within the blockchain. This is nothing more than just creating a random private key and computing the corresponding Bitcoin address. People, or hackers in particular, cannot reverse engineer this Bitcoin address to get the private key. This address is also known as what we call the public key. The owner must know the corresponding private key in order to be able to do anything with their Bitcoins and digitally sign the transaction. The Bitcoin network would not accept any other proof of possession if the private key is misplaced, which makes the Bitcoins rendered unusable and effectively lost. As such, the private key must be kept secret. If the private key is leaked, it may be exploited by the third party to seize the associated Bitcoins. Due to the popularity of the Bitcoin currency, many currencies, goods, and resources can be traded with Bitcoin. Now, it is helpful to grasp what Bitcoin mining actually means before you start mining Bitcoin. Bitcoin mining is legal and is done in order to verify Bitcoin transactions and provide the necessary protections for the Bitcoin ledger by running SHA-256 double round hash verification procedures. The Bitcoin network compensates Bitcoin miners for their computation efforts with giving Bitcoins to them. This comes in the form of both newly released Bitcoins and the processing fees from processing transactions. The more resources you devote to computation, the higher your share of the award. The things that you need for Bitcoin mining can be split into two categories, which is the software and the hardware or the infrastructure. Now, the hardware and infrastructure portion will be the heart of this course, as I will delve deep into getting the optimal hardware and infrastructure to build a high caliber Bitcoin mining farm. However, let us look at the software portion in this video. The Bitcoin mining software is of course essential to your Bitcoin mining operation. The software is very much dependent on the hardware as well as the operating system that you use. Now, the most popular Bitcoin mining software might change over time. So what I'm going to tell you right now is going to be what's popular at the time of this recording. In this case, it will be the CG miner, the BFG miner, and the Easy miner. Now, the CG miner is a command line mining application, and this software allows the user to configure a lot of things such as overclocking, remote interface, the fan speed on your device, etc. The BFG miner, on the other hand, is another command line software that is similar to CG Miner, but with more cross-platform options. Heck, it even supports installation in Raspberry Pis. But, I actually don't know why you would do that besides having fun with it. One downside for this particular one is that it doesn't actually support the GPU mining support. Lastly, for the Easy Miner, unlike the above two, this particular miner software is actually a GUI based. So it is actually a lot more user-friendly and actually a lot more graphically appealing. After all, it's better to look at an interface than just looking at the command line, right? Of course, GUI uses computation power, so you won't be seeing it being as efficient than the command line based ones. Now, aside from the mining software, another software that you would need is the Bitcoin wallet. Bitcoin wallets make sending and receiving Bitcoins simpler and grant the recipient control of the Bitcoin balance. The wallet for Bitcoin comes in several forms in both software and hardware format. A trader must create a Bitcoin wallet to trade in Bitcoins, as the wallet holds relevant information such as the protected private key used to enter Bitcoin addresses and carry out the transfers. The most secure format is actually the hardware wallet, where the information is stored in a secured USB device that is then plugged into the USB port of whatever your device for mining Bitcoins or collecting or using Bitcoin will be. Now, the least secured option for Bitcoin wallets, on the other hand, is the web wallets, where it is actually stored in some unknown website. It is important to keep your Bitcoin wallet secure, as Bitcoin wallets are targets for hackers. Some protections that can be adopted include encrypting it with a strong password in the wallet or selecting offline saving option, like what I mentioned earlier, use a secure format like the hardware wallet. It is also advised that your desktop and mobile wallets be backed up periodically, as issues with the wallet program on your computer or mobile device may render your Bitcoin holding useless. I understand that many people might only want to just get right in without wanting to make it big with a Bitcoin mining farm. If that is the case, this course may not be for you, as the subsequent lectures are all about building the state-of-the-art infrastructure to maximize the earnings in a mining farm. If you just want to get started, there are two easy methods with low investment needed. Of course, this also means that you will have low returns as well. The two things that I want to introduce to you are the Bitcoin mining pool and cloud mining. Bitcoin mining pools is essentially a group of people with their mining hardware grouped together to solve a block. The thing is, if you wanted to start small without much investment, you may mine for years wasting electricity without earning a single Bitcoin. With Bitcoin mining pools, you share the mining work with a group or pool of people. This means that you're all pooling resources together to mine Bitcoins. Of course, you will also share the rewards as well, so the reward will be split between the miners plus the operation cost of the mining pool itself. Common Bitcoin mining pool includes the P2 pool and the Bitminter, but of course there are many others as well. For those of you that don't even want to own any mining hardware, I recommend you to check out something called cloud mining. In fact, a very good business model of which it applies to the contents of this course is to build a cloud mining facility. This means instead of mining your own coins, people are renting out your facility to mine theirs. Cloud mining is a process that utilizes least cloud computing resources to mine a cryptocurrency, such as a Bitcoin without needing to operate the hardware and associated applications directly. Cloud mining companies encourage individuals to open an account and partake in the cryptocurrency mining process remotely for a basic fee, making mining available to a larger range of individuals around the globe. Because this type of mining is performed through the cloud, problems such as equipment repairs or direct energy costs are therefore minimized. In relation to the amount of hashing power rented, each participant receives a pro rata share of the income from the mining. The most common method of cloud mining is actually called the hosted mining. The client purchases or rents mining machinery installed in the miner's facility in this model. The miner is responsible for the repair and functioning of the machinery. Customers have full influence of their cryptocurrency through this model, whether it is you're mining Bitcoin or Ethereum, etc. A mining farm's economies of scale mean that expensive mining related costs such as power and storage become manageable. But this method of mining is associated with a substantial upfront expense, as the renters will need to pay a monthly rental fee for the mining. And as a business, mining companies charge a cost to make sure that they will be sustainable as well as earning a profit at the same time. With the subsequent videos of this course, I will teach you the things you need to get a mining facility going, whether or not it is for your own or your client's Bitcoin mining, or what we call the Bitcoin mining farm, or build it for cloud mining businesses. Are you ready for making it big in the cryptocurrency world? I know I am, so let's get started. In this video, I am going to talk about the mining hardware that you would need for your Bitcoin mining farm. For the mining hardware, I will look at it in two categories: the GPU miners and the ASIC miners. I have to say, you will only need ASIC miners, as the GPU miners are probably now obsolete. Regardless of which, I will still go over both types. Let's get started. Let us start with the GPU miners. As the name implies, the focus of these rigs are the GPUs, or the graphical processing unit. As you would probably know already, they're always the next best thing that comes up for essentially all computer hardware. So it is basically a moot point telling you what to get, as what I tell you today may be useless for tomorrow. Instead, I'm going to tell you in general what you need as a general rule to build the best GPU mining rig for the facility. When choosing the components for your rig, the most important parameter is the thermal design power. This is also known as the TDP, which is essentially the max heat generated by the component in typical operations. So let us look at each of these components individually. Let us start with the CPU. In the GPU miner, the CPU is not actually really important. So don't go crazy in getting the latest model, as the most important is to get the best output with the least cost. You should instead pick the one that has the lowest thermal design power as possible, so it will consume the least power as possible for the rig. As motherboard, one thing to keep in mind is that you should pick the motherboard first before you pick the CPU, as that is a much more important component for the miner rig. Whereas what motherboard you use dictates the CPU type and RAM that can be supported, the main interest here is actually the number of available PCI Express slots that it has. Typically, we want to expect one with 4 to 6 PCI Express slots available, but of course, the more the better. Note that even a PCI Express X1 slot would have enough bandwidth for what we need. As for the RAM, I would say 8 gigs usually would be okay for the GPU miner rigs, and the RAM speed doesn't really matter for our application. And of course, the most important part of the GPU rig is the GPU, or the graphical processing unit. The mining hardware that you will use utilizes 100% of GPU power, so the most optimized or lower thermal design power GPU should be chosen. This means that it would in turn lower the energy consumed and generate less heat. Note, I said optimized, not the lowest, as we need to look at a much more important factor here, which is the performance. With that in mind, I want to introduce you to another parameter, which is the flops, which is a measurement of the GPU's computing performance. With that, along with the TDP, we can calculate what is called the performance per watt, which is flops per TDP. The higher the result, the higher its efficiency. Other things to keep in mind when sourcing the GPU is that it should have more than 3 gigs of RAM, an open air design, and you should actually also keep having all the same GPUs within the rig, so that all of the GPUs within this particular rig should have the same model and the same type. So basically, I would recommend you to purchase all of the same GPUs at once. Another thing that I would like to recommend is to get GPUs with a back plate, as not only it provides extra protection, but also have better heat dissipation as well. Now, next thing we want to talk about is the power supply. The most important part for the power supply is its output power, as you're going to power several high-powered GPUs. I would recommend to spec the power supply by assigning 200 watts to each GPU that you have in your rig. As for the cooling fans, one thing that you should be familiar with is what we call the CFM, which is the cubic feet of airflow per minute measurement. This is an indicator on how much air the fan could move. For the mining rig, you should look at airflow fans that have a high CFM. Allow 150 to 200 CFM allocated to each GPU in your rig when speccing these fans. Lastly, let's talk about the chassis. There are two types of chassis available, which is the closed air and the open air. The closed air chassis is the one like your normal desktop computer, whereas the open air chassis is the special one where basically it is actually not an enclosure, so because everything is actually open. What makes it the lack of protection will also allow better airflow. With the GPU mining rigs, the open chassis is often the recommended option. What truly matters when it comes to cryptocurrency mining is that the cryptocurrency you mine is worth more than what you invest in machinery and energy. Since cryptocurrency mining can be pricey, these margins can be closer than you may expect. It can be pricey to purchase hardware up front, and some of it can cost thousands of dollars a year to operate on energy. Having more energy efficient rigs is enormously critical when selecting mining hardware, and that is where ASIC mining rigs come in. They differ from a GPU rig, which depends on components designed to perform more than just one operation. Instead, from the ground up, ASIC miners are programmed to perform the calculations needed by a particular cryptographic hash algorithm used by the cryptocurrency in question. They're extremely fast, powerful, providing a high hash rate and energy efficient because of this single focus, consuming much lesser power than a GPU miner rig with 8 GPUs that do for the same job. This combination of reliability and low power consumption makes them much more affordable to use than hardware for more general purposes. In fact, ASIC miners are actually the only way to go, as the Bitcoin block algorithms have gotten so complex and intensive for the GPU miners to do. These can usually do billions of hash rates per second, with the top of the line ones going to the trillions. What is even better is that ASIC miners often have closed air chassis, so it has an enclosure, unlike the GPU rigs. Now, you might ask, Mike, why are you then teaching me all about the GPU rigs? Now, the thing is though, things change over time. So there's a lot of unknown factors within the future of Bitcoin mining. So In the future, you might have the capability of building your ASIC mining rigs. And in an essence, even though that ASIC miners are pretty much focused on doing one job, which is mining Bitcoins, it is still pretty much a computer at heart. But for me, I would even put Raspberry Pis as just a semi-computer, even though that, as many of you know, it's basically not. However, the components are relatively the same. So by knowing what the inside of a GPU miner rig is, what are the components inside, and what it should be look out for, can actually help you in understanding how these rigs work and allow you to maybe future-proof your business. And when the opportunity comes up, when they allow you to build these from scratch, it actually would give you a better knowledge in how to build a top-of-the-line miner rig for your operation. Let us now look at the generated heat from these rigs and how it affects the lifespan on their components. Conductors such as gold, silver, copper, and semiconductors such as silicon, germanium, and selenium are the materials that form the electrical components of every computer hardware, or in this case, every rig hardware. These materials' physical and chemical properties change as the temperature changes. For example, with an increase in temperature from 20 degrees Celsius to 100 degrees Celsius, the internal electrical resistance of copper rises by around 20%. And not just copper, materials expand as the temperature rises in general. These expansion may create electrical interference that is unwelcome, and the components may not function as they're supposed to. Consequently, if it is not built to tolerate such a rise in temperature, an increase in temperature will make components as well as the entire system to be in an unstable state. To solve this, you can either engineer the system to work at higher temperature or by cooling the modules back to the desired working temperature. Of course, the former is the better solution, but it is also a more costlier solution. The capacitors are the most common electronic components that are used in computers, or in this case, mining rigs. However, the parts used in these systems are also extremely vulnerable to heat. Constituents of the capacitors begin to alter their chemical and physical properties and deform when they're exposed above the designed operating temperatures, and thus the capacitors that are within your computer or your mining rigs will start to break down. On the product specs, the design operating temperatures are usually mentioned. For example, the operating temperature of ordinary aluminum electrolytic capacitors is around plus 85 degrees Celsius, with the new solid capacitors commonly used in computers that can be operated to more than 100 degrees Celsius. But of course, this high temperature of operation can only last for a short time, as the lifespan of less than 2/3 of a year can only be sustained if you are operating at this temperature consistently. So what happens in the context of the real world? Why do some desktop computers, despite not having a good cooling solution, last so long? Well, the thing is, most normal usage of computers or electronic devices, they are actually not running all the time. They may only run at most a few hours a day. Another thing is that, for example, computers usually utilize cooling solutions that keep it cool even under heavy workload conditions, so that the temperature rarely exceeds 90 degrees Celsius. The cooling heat sinks and fans are designed to maintain a suitable working temperature. And further to that, the electronic components within a computer have protection mechanisms, such as they shut down to prevent being affected when the temperature reaches the specification threshold. Now, going back, why is heat such a concern for mining rigs then? why are we talking about heat? Well, for one thing, these rigs operate at 100% of the GPU's capacity for 24/7. And these rigs need to run continuously for a long time. And of course, mining rigs in general are very costly. Also, because most mining rigs are run remotely, so that means that system reliability is actually much more critical than for a standard desktop computer. After all, if you need to drive hours and hours to your mining farm just to actually replace or restart a mining rig, you would need them to be more reliable. What this means is that the heat is a concern in mining rigs because heat in general shortens the life of the mining rigs, and they also create instability to the rigs as well. As such, you would want them to have less heat or at least not be affected by heat as much as possible. The optimum safe operating temperature for a GPU is around 80 degrees Celsius, as stated earlier. And above 80 degrees Celsius, the GPU will render unstable and typically throttles down. Furthermore, the life of the components above this temperature would actually be lessened as well. And you might think that this applies only to GPU mining rigs, but this actually also applies to ASIC miners as well. So you should actually be cognizant about the heat that is going to be generated in your mining facility. And of course, we are going to talk more about heat and explore the cooling schemes that you will need to implement further down in this course. In this video, probably actually one of the most important video, or at least the most interesting for you to learn. And this video is focusing on mining rigs and your income. So I'm going to actually talk about the various aspects of mining rigs that can actually lead to an effect on your income. And I'm also going to go over a high-level calculation and high-level example on how you can calculate your overall profit from Bitcoin mining. So let's get started. For Bitcoin mining operations, there are many variables that affect your earnings. And they are the ones that you can see right now in front of you. The first one is the system's average hash rate. Hash is a cryptographic feature that takes an entry and returns an alphanumeric string of a fixed size in what we call the hash value. Now the second variable is the network's difficulty. This is, in very general terms, the amount of effort needed to mine a new block. This depends on the network's overall hash rate. Remember, the more miners there are, the higher the network difficulty. The third variable is the price of a Bitcoin. A higher Bitcoin price is contributing to increased profits. And lastly, the last variable is the overall electrical power cost. And in this case, the general rule is the cheaper the electricity would lead to higher the profit. With regards to cost and requirements of the miner, the following 5 factors need to be taken into the account, which is the cumulative cost of a mining system, the depreciation and loss of value of the system in the long term, for example, over an expected life cycle of the mining rig, the physical space needed for a mining rig and its associated costs, the maintenance requirements of the rig, as well as the cost of a disruption to the mining process. Where the cumulative cost of the rig itself is pretty explanatory, let's go to look at a depreciation. Electronic devices, such as that of computers, usually suffer from a loss of value for 2 reasons. One being the natural mechanism of depreciation, and 2, the reality that newer models are continuously being made available. In particular with number 2, much consideration needs to be made as the network difficulty will continue to increase, which means that the return that you get from your mining rig will diminish over time. So you need to consider whether or not you need to keep using it or buy another, newer, shinier rig. You might think that you can sell your rig to get a nice salvage value out of it. But the thing is that it is not as rosy as it sounds. If you have an ASIC rig, if you don't want it, not many people do as well, since it means that it is an outdated version, which means that it is inefficient. Therefore, it is useless. Couple the fact that it is actually used, which means that it has significant wear and tear due to 24/7 operations. For GPU rig, it actually still have the wear and tear problem, but you can actually reuse it to repurpose it for other functions. So it may actually have more salvage value than the ASIC rigs. So now let us look at the space requirements. The two main consideration factors for space requirements are noise and heat. Mining rigs are loud, especially if you're running an entire plantation of it. But if you're running a mining farm, with which it is an isolated facility where you just remote in, you shouldn't need to worry about it much. As these rigs operate 24/7 non-stop, they also generate a lot of heat as well. There may be a way to use this warm exhaust air from multiple mining rigs within a farm. Maybe, for example, to heat up a boiler. But recycling the hot air that requires a lot of preparation, which makes the whole operation even more complex and costly, and often many times more than the actual expense of the whole mining system or the mining farm itself. So the easy and functional approach is to just route the warm air out with simple air channels or ducts. We will look into this topic much later in this course. For maintenance, this is more or less applying to the facility in general. As the rigs usually have short lifetime, not much maintenance actually needs to be done besides routine inspections to make sure that there are not signs of incoming failures. As for disruptions, the cost will very much be an estimated cost as to the probability of disruption happens and the cost of getting it back online. This may also have an opportunity cost associated with it, but it is at the discretion for the estimator in this case when calculating the impending profit margins. Alright, so let us go over a high-level income calculation. So let's say we bought an ASIC rig for $5,000 with a hash rate of 110 trillion hash per second. This rig consumes 2,000 watts at a cost of 10 cents kilowatt hour. We're not going to calculate this by hand since there are one too many online calculators out there that are tied to the Bitcoin difficulty chart and the current Bitcoin market price. So it is a moot point to calculate all of this information by hand. So there are a lot of these Bitcoin calculators available online, but in here I'm going to use the website which is shown in front of you, buybitcoinworldwide.com/mining/hardware. You can actually use any one you want. I just use this for myself. If we actually plug in the numbers that I've provided you as the example, you would actually see that there are a lot of details that they produce, which is, let's say, the profit per day, the amount that's mined per day, the electricity cost that's being used per day. So in here, overall, when you look at per year, let's just say, you would actually have around the profit of $12,180.25 of profit per year for this particular mining rig. And that's basically just a forecast based on the difficulty that we have with the current blockchain, as well as the current projection of the Bitcoin price. So, of course, I'm saying that I'm going over a simple calculation, so I'm not just going to tell you to plug everything into an online calculator and the online calculator would do the rest. Heck, the rest of these calculations, you probably couldn't find an online calculator to do it. So let's continue on with what we have based on the profit per year that we calculated through our online calculator. From the example, you know that your rig costs $5,000. So now, let's say the perceived lifetime is 3 years for this rig before you need to replace a new one. And since it is an ASIC rig, I will assume a $0 salvage value. Now, if we do that, the math for straight line depreciation is basically your initial cost minus your initial your salvage value divided by the lifetime in years. So in this case, since the salvage value is $0, it would just be 5,000 divided by 3. So your yearly depreciation will be $1,666.67 per year. So let's just assign this particular value to your profit. I would actually just say that instead of looking at it as a depreciation, I would just look at it as a per year usage of that rig based on its lifetime. So it's the usage cost of your rig per year based on that your rig can only last for 3 years. So when you do that, you know that your profit from your online calculator is calculated as 12,180.25. You just minus the 166.67 from it, which equates to $10,513.58. So that would be your yearly overall profit minus the cost when you assign your yearly usage cost of that rig to your profit. Now, let's say we're running a mining farm operation with 1,000 of these mining rigs. Well, if that is the case, the yearly profit will be equal to $10,513.58 times $1,000. Well, that equates to $10,513,580. Now, that might be a lot of money, but we have actually not accounted for the place that we're going to store all of your mining rigs for your operation. So we haven't accounted for the facility yet. Hypothetically speaking, let's say we need a 3,000 square feet building to be built, and the quote in a remote location is $1,000 per square feet. This means that you will actually need $3 million to start. Now, if we need to borrow from the bank these $3 million at 3% in 10 years, then we need to use the loan payment formula, which is P equals to R times PV divided by 1 minus 1 plus R to the power of minus N, where PV is present value, R is the rate per period, and N is the number of periods. Let's say that there are yearly payments, so for 10 years, so N will be 10. Plugging into the formula, we will then have P equals to 0.03 times $3 million divided by 1 minus 1 plus 0.03 to the power of minus 10. And that equals to $351,692. So we need to get the payment to be deducted from your earnings. So that will be what it's left, which is 105,13580 minus the 351,692. This equates to what you get as $10 million, $161,888. Now, let's say that your maintenance and operating costs would net around 50 grand per month, which includes utilities other than electricity, maintenance, security, etc. Your overall cost would actually be around, well, your leftover yearly revenue would actually be around, with the formula, 105,13580 minus 351,692, which is equal to $10,161,888. And there you go. This is the high-level rough estimation as to the income that you get when running a Bitcoin mining farm. So welcome to the heart of this course, section 2, which is the considerations that you will need in order to build a state-of-the-art mining facility. Of course, the first step in the process of constructing a new Bitcoin mining farm is to determine the criteria for what sort of facility you need. Before anything, you need to know what's your objective before you start putting stuff down on a sheet of paper. The first step is identifying the new mining farm needs. To both start the procurement process and to have a fruitful discussion with prospective suppliers, contractors, consultants, and builders, there are a few main pieces of information that are needed. Don't get worried about this list as we go forward, because we will discuss each requirement that I list in more detail throughout this course. So, what do we need to consider? We can break this down in the following categories, which is space, power consumption, network requirements, redundancy or availability, and location. Space is usually referred to the square feet that you need, but how much square feet that you need is another question. One way you can start is to count the number of cabinets and the number of rack units used in each cabinet. We're going to explore this in more detail, but you need to prepare for items like cabinet width and depth, I/O width, cable, and ventilation space, as well as non-equipment rooms, such as for storage of parts, etc. The next is power consumption. The power consumption not only includes your mining rigs, but also any facility consumption such as lighting, electronic locks, routers, etc. You will need this to source the service size that you need, which would need to be communicated to the local utility company. I would also recommend to look at the projected power consumption as well, in the case that you want to put more rigs or higher power rigs. You should put a buffer and not to size it as stringent as possible. The thing is that if you size it as the stringent as possible, you might have cases where you have overload, or if you actually want to have some sort of changing of rigs that might require more power, you might overload your service, and you don't want that. So you should actually put a buffer to whatever that you estimate for your projected power consumption. Next is the network requirements. While the data requirements are actually not that huge for crypto mining facility, you still need all of the rigs to be connected to a network. So you would need to consider what kind of service that you need with thousands of rigs connected to a central network with which you can remote in off-site. Then you will need to look at the redundancy and availability. In this case, the loss of availability means loss of income. So of course you want your machines to be up at all times. But at what cost? Well, this needs a further cost and benefit analysis to find out. Lastly, location. For location, you need to look at a place where the cost is low. However, there are various criteria that you need to look at, and there are no set formula in defining the best location. The land price might be low in very remote and rural areas, but getting power there might be costly if there are no infrastructure there to support your mining operation. You may also need to find areas that are stable, such as low probability of earthquake and flooding, etc. We will look at each one of these in more detail. In this video, I would like to talk about some pointers of where the mining farm should be located. So now let us go through the list of requirements as can be seen in front of you right now. Let's start off with floodplains. First of all, you should avoid building your mining farm on a location that has flood risk. Flooding will cause your entire investment to be permanently damaged due to water. Yes, floodplain locations are usually cheaper and there are mitigation technology to reroute water. But why take the risk? You can get a flood risk information usually from any local government, so I recommend you to review it against any location that you are interested in. The next thing is relevant distance. When I'm talking about relevant distance, I'm referring to distance from you and your operation team from the mining facility. I know that you most probably are going to remote into your operation for most of the time, but I would advise you to locate it within an hour drive from the site to where you and your operation team are situated in. The reason for this is so that in the case of situation that you will be required on site due to certain emergencies, you can still arrive promptly. Lastly, it is neighbors, and this goes towards if you are sharing the same building or different buildings but close by. You would want to know how risky the location is to your mining operation. For example, if other businesses deals with a lot of explosive materials or other chemical products, you should actually avoid building the mining farm near these businesses. Now, the last three requirements are the responder proximity, major roadway proximity, and the nuclear risk. Now for the responder proximity, this is just a good to have, but not a must. The proximity of a fire station allows the firefighters to respond to fires on or around the vicinity to the mining farm, and proximity to the police station may deter the possibility of theft. Again, the proximity to responders it's just nice to have, and it allows you to have a peace of mind as you will know that the firefighters and the police can respond promptly to any emergencies that occur surrounding your location. But again, it's not an absolute requirement. Now the next thing is major roadway proximity. I personally would avoid major roadways as it has risk for potential vehicular accidents and such. But again, it is not a huge major concern as you shouldn't be anticipating that people would go from major roadways directly to your site and crash into it. However, though, given a choice, I would not want to cite a place that it's next to a major roadway where there are a lot of cars. Now lastly is the nuclear risk, and the main reason is that there is a 50-mile evacuation zone for nuclear power plants. So a 50-mile area around the facility would be subject to evacuation if there is any kind of a radiation spill or any more significant incident. So in this case, I would recommend to avoid this 50-mile radius from any nuclear power plants. But again, these last three in general are actually not major requirements, so it's just a nice to have. For example, the nuclear risk, right? Even though that it has an evacuation zone in which if you are situated 50 miles within a nuclear power plant, you will need to be evacuated. However, though, mostly you would be remote into your mining facility, so it won't be applied to you. It won't cause inconvenience to you. But if you, let's say, have a security team, then you might have the security team be evacuated when such things occur. So again, It's not a make or break deal if you got a nuclear power plant close by, but it's a nice to have, and it's preferably to avoid that 50-mile zone. Before you are building your Bitcoin mining farm, you will need to know the amount and type of space that you need, as failure to precisely communicate what you want in terms of space will definitely hurt your future operation. So in this video, I'm going to go over the consideration points for you in terms of facility space for your mining farm. Let us start with white space. White space is defined as the area with which your mining equipment is placed. Now, the white space is three-dimensional, which means that if you don't have enough floor space, you can make it up by building upwards, which means higher cabinets and racks. Now, with floor space, please do keep in mind that we need to also provide accessibility space so that we can access our rigs comfortably for maintenance or replacement work. Also, we need to include space for cable routing and proper airflow. With flooring, especially if you have a greenfield facility design, you can choose between raised floors and hard floors. Let us look at these two options. Let us start with the raised floors. The main use for these is for airflow circulation, such as the targeted and enclosed architecture that I will be going over in the later cooling section. Now, aside from cooling, you may consider raised floors for the purpose of routing cables or establishing a ground grid for your equipment. Having raised floor has a distinct advantages, being that it allows easier way to direct airflow as well as the ability to reroute cables more easily. However, on the other hand, it comes with a range of disadvantages as well. For example, point loading is an issue to heavy equipment focused on a single point on the floor may actually wreck the floor itself. Furthermore, if you need to reroute cables, it is actually harder to reroute in under the raised floors, and to top that off, you cannot congest the raised floor space too much or it will impede the airflow. And speaking of the cable rerouting, you will need to remove the tiles while rerouting, which means that if you remove too many at the same time, you might create too much stress for the infrastructure, and if you forgot to put some tiles back in, you might injure someone when they accidentally stepped into the hole while maintaining the rigs. Of course, the other option is the hard floor. This simply means that all of your equipment is placed on just concrete slabs. With this option, there are two advantages to it, such as that it is cheaper and it's less susceptible to damage. As for the disadvantages, it is mainly that all the cooling and cabling will need to be fed overhead through ductwork. And if you need to reconfigure ductwork, for instance, in rerouting cables, it is actually much harder to modify ductwork than pulling just a few tiles underneath. Let us now talk about the fire suppression system. In a lot of facility designs, the fire suppression system is often just an item in the checklist for many facility builds, including mining farms, and there are not many considerations being put towards it. The main reason being is that while power and cooling are vital to the farm's everyday activity, fire suppression only comes into play when something has gone wrong. Now, to be quite honest, you do have little to no control over the fire suppression system, especially if you are in a co-lease space or brownfield construction. That said, you should still know what is in place and how the system protects your mining farm. So now let us go over the major components of the suppression system. And there are 5 components in general, which is the fire alarm, extinguisher, EPO switch, delay switch, and the agent. The detection system is intended to determine whether a real fire has begun or just a false trip. And to prevent false alarm, the detection system should detect both smoke and heat. As for the fire alarm, The fire alarm itself is to signal appropriately that anyone needs to evacuate. So this should include both sound as well as visual, such as in the form of blinking lights. They should usually be described within the required building codes. So the look and feel of fire alarm is basically defined by whatever that's set up regionally in your local building code. Now, as for the fire extinguishers, it needs to be installed at key positions within the mining farm facility. The need for portable extinguishers may seem unnecessary, as the facility usually have an automated suppression system of its own. But in reality, this is to ensure that the workers have a way to extinguish fire between themselves and the exit from the facility, which should be included in the design. Now, also another thing is with the portable extinguisher is that if you see a particular equipment is just starting a small fire but has not been spread, the particular worker can actually use the portable extinguisher to actually quickly extinguish the equipment. And usually these extinguishers, even if you use it, it won't harm your equipment. So in this case, not only the people, it would also protect the equipment as well. So the next one is the emergency power off switch, or the EPO switch. In the event of a fire, the EPO or the emergency power off switch will automatically cut off electricity for safety. In addition, in the case of a catastrophic event, such as the electrocution of a team member, there is also usually an EPO switch that needs to be installed in critical locations, such as a main entrance door for manual power cutoff. Again, a lot of things here is to actually prevent harm to you or your team that it's operating within the mining farm facility. Then there is the delay switch, which is a switch used to delay or cancel the suppressant dump in the case of a false alarm, or whether the personnel needs more time to get out of the facility before the fire suppression system dumps the suppression agent. And lastly, of course, there is the suppression agent, and this is the material used to extinguish a fire. Ideally, the facilities will not be ruined by this suppression agent, and it won't take too long to clean up. However, though, this may not always be the case. The suppression agent may range from various kinds of gaseous suppression system to just a water-based agent. Having just said about the suppression agent, let us look at the types of suppression system. There are generally three common types of suppression system, and they are the water-based, the pre-action, and the gaseous-based system. The water-based basically uses a sprinkler system, and the second one, the pre-action, is still using water, except that the pipe is kept dry until a fire is actually being detected. The third system, and also the most expensive one, is the gaseous-based system. This system utilizes agents that removes oxygen and heat from the environment to extinguish fires. Although your rigs might not be damaged by water like the other two systems, the agents in the gaseous-based system is not human-friendly, so you need to be sure that the workers or whoever that is inside, including yourself, can evacuate before the agents get released. So hence why you get the delay switch that I have introduced to you just moments prior. Again, your choice is very dependent on the facility space that you're using, so there is very little control on what you have as a suppression system. Another space, as I mentioned earlier, that is very important for you to consider is the vertical space. And the vertical space needed is very dependent on a few things. The most important part is the height of the cabinets or racks that you will be deploying. Then the layer of cables that you're going to have above the cabinets or racks, and then the ductwork above. Of course, the most important equipment in this case is the cabinet. The level of scale of your farming operation is often than not determined by the cabinet space that you can have within your farming facility, as this limits how many rigs that you can have installed. Thus, you need to pick your cabinets or racks carefully when you're constructing your farming facility. Cabinets and racks are measured in what is called the rack unit. A rack unit is usually 1.75 inches in height. You need to look at the specification of the rigs that you want to buy to see how many rack units it takes up. Some of them will say it in their specs, mostly when you are buying GPU rigs. Some ASIC rigs only supply dimensions, and sometimes they are not compatible to be installed in traditional cabinets. If your ASIC rigs are not compatible with traditional cabinets, then you need to procure or build a custom mounting structure to house these rigs vertically. I would say a lot of the ASIC rigs do have compatible mounting brackets to be installed on traditional cabinets or racks. Lastly, I wanted to go over other miscellaneous spacing requirements. The standard width of the cabinets are 24-inch, but sometimes you might want to prefer wider cabinet solution just so that you can have better cable management. So in that case, I would actually recommend to use 30-inch width cabinets just so that you can manage your cables more effectively. And speaking of cable management, you need spaces between the top and bottom of your rigs for accessibility and, of course, again, cable management. So be sure not to jam-pack everything, all of your rigs together with no spacing between it when you are calculating how many rigs you can have within a cabinet or a rack. Now, I would also recommend to leave at least 3 feet between the rows of cabinets or racks to allow accessibility for maintenance as well as to optimize airflow. Outside from that, the cable is another important factor when looking at the space that you need. We will look at cabling in another video of this course. Lastly, you may have backup generators, switches, as well as other items such as electrical panels, etc. And most of these will require specific clearances as well as other miscellaneous requirements. These requirements will differ depending from where you are located, so please check your local electric code for further details. Perhaps the most significant component of the Bitcoin mining farm design process is the emphasis on supplying the mining equipment with the adequate power. You may or may not have any experience and knowledge of power and electrical system, and in many ways in which they supply power to your mining farm. So that is what this video is for. We will analyze the electrical system and how electricity is distributed all the way from the generation plant to the receptacle into which you plug your equipment, before we discuss the specifications you need to specify for your Bitcoin mining farm project. So, how electricity is supplied to the mining facility is essentially based on how you determine your requirements. You will never need to know the in-depth architectural considerations of the electrical utility portion unless you are studying to become a utility power engineer like myself. However, you will need to know the portion of which it supplies power to your facility, as knowing what options is the best will save you in a lot of time and cost. In simpler sense, the multiple distribution configurations can be split into 4 general categories that is shown in front of you, which are the single feed single substation, the dual feed single substation, the dual substation, and the real dual feed. Let us go over each one of these in more detail. Most of the mining facilities should fall into this category. This is by far the simplest and the least costly approach. One funny thing is, I even see many more crucial operations, such as data centers, utilize this configuration, but they also had a false sense of security, thinking that they were fed from multiple feeds. Let's look at the diagram in front of you. In this configuration, you'll find in this setup that there is only one single feed from a single substation. The facility is then connected to several local transformers fed by the same source, giving more than a single feed appearance at the facility. This gives a false sense of security, as if there is anything happen to the main feed or substation, the facility will be without power anyways. However, I would recommend a single feed, single substation approach without the need to have multiple transformers feeding into a mining facility. The reason is simple, because this is the cheapest option. But then you might ask, Mike, what happens if there is an outage? Wouldn't this cause my farm to be without power and may even damage my rigs? Well, I will get back to this later in this course. Although I have given my recommendation on the configuration to be used, let's still go over the other ones that you may want to consider. Keep in mind that these are much more costlier solutions but offer more stable supply of power from the utility. So let us go over the last three configurations. So the second one is the dual feed single substation. This differs from the previous configuration by adding one additional feed from a single substation, where the feeder is chosen using a throw-over switch. This in turn eliminates the risk of a single line breakdown, triggering a sustained outage by providing two distinct feeds. With the use of only one substation as the power source, this configuration nevertheless still holds a high probability of extended power outages. Not only that, the feed downstream of the switch into your facility is still maybe susceptible for a single point of failure. The third configuration is the dual substation. With this configuration, you still have a throw-over switch, but now the two feeds are coming from two different substations. Again, the feed downstream of the switch to your facility is still maybe susceptible for a single point of failure. And the last configuration is called the real dual feed. With this one, there's no throw-over switch, and both feeders, each are going to be from a different substation, is going to be directly fed to the facility. And inside, each should be redundantly supplying power to your assets or rigs. And this last one is going to be very, very, very reliable, but it's also going to be very, very, very costly as well. With your mining farm, the most important part of the infrastructure is the power, as it powers up your rigs. Power outages, if not handled correctly, will damage your rigs. Also, your mining farm will most probably at a remote location where it would take considerable effort to get all of the rigs back into operation. As such, it will be in your best interest to have a state-of-the-art electrical design and minimize the outages to a minimum. Before starting on looking at the design itself, let us go over some terminologies. This is important, especially if you have no knowledge of electricity prior. Of course, without boring you to death, my explanation is simple. You need to keep tabs of the power needed in watts or kilowatts of all of the equipment that you need within the farming facility. And I'm not only referring to your mining rigs in this case, I'm referring to all of your equipment that uses electricity, such as your lighting. One of the key design priorities would be to improve the facility's power efficiency, which means that any design inefficiencies need to be fixed and planned whenever possible. Some examples of improving electrical efficiency for your farm includes using LED lighting and a UPS with very efficient and low loss, and so on. It is also necessary to reduce any power loss through the cables both outside and inside the farming facility. This is of particular importance in mining farms, as the loss of power will result in heat generation. Depending on the scale of the mining farm, your local utility may offer you with two solutions on their utility feed. What I'm talking about is not the configuration, but the voltage of your surface. If your mining farm is still considered as a small scale, utility companies may just install a pan mount transformer close to your facility and supply you power in the 120 to 600 volt range, or what we call the secondary voltage range. Now, after your power requirements reached a certain level, and this kind of varies between utility companies, so I couldn't tell you at what range will they be looking at this configuration, the utility company may simply supply you with a service feed that is of medium voltage. What I mean by medium voltage is from 4 kilovolts to 35 kilovolt range. With medium voltage service feeds, you will need to have a step-down transformer within your facility to step it down to secondary voltage level ranges to meet your equipment needs. Now, in terms of services, there are also differences between a single-phase and a three-phase service. Single-phase service is mostly residential services where there are 3 wires with 2 hot wires and a neutral. For example, in a 120 volt single-phase system, 120 volts will be supplied by 1 hot wire and a neutral, while 240 volt can be supplied to more power-intensive equipment such as washer and dryers with the 2 hot wires. However, with your mining operation, you will most likely be accustomed to the 3-phase 4-wire system, where it is usually supplied from a Y secondary, and it is essentially 3 wires of 3 different phases and a neutral. Less common will be having the 3-phase service being supplied by a delta secondary transformer, where now you will have 3 wires instead of 4 going into your facility. The reason for the 3 wires only because delta connections would not have a neutral. Current rating is essentially the limit as to how much steady-state current an equipment can safely sustain. The electrical equipment's rated current means that the equipment can maintain the current continuously without reaching its temperature limit. For example, the temperature rise. This is a very important parameter for electrical components. If any type of current limiting mechanism within the equipment itself cannot stop the overcurrent, the device will surely heat up and catch fire. The rated current is also the highest amount of current a device can draw. However, this rated current does not refer to the real current that a device will draw. In most instances, much less than the rated current would be drawn by your equipment, even for your mining rigs. The reason is mostly because exceeding the electrical equipment temperature cap will lead to failure of the equipment or even fire. In a Bitcoin mining farm, all electrical devices must be shielded from overcurrent situations, such as overloads and short circuits. For this purpose, a component within, like a circuit breaker, will be integrated to guarantee that the rated current are not surpassed. These components are responsible for opening a circuit in conditions that are overcurrent. For all these types of components, it must be able to tolerate brief bursts of overcurrent pressures before activation of the overcurrent protection system, as we don't want any false trips. In a mining farm facility, there are different types of equipment deployed to supply power to the rigs in both a redundant and complex manner. Here's the list of common types that you need to know in front of you, which is the switchgear, the panel boards, the switchboards, the power distribution units, and the uninterruptible power supply. So let's start off with the switchgear. The switchgear contains a mix of electrical disconnection switches, fuses, or circuit breakers used to operate secure and separate electrical equipment. In order to allow work to be performed and to clear faults downstream, switchgear is used for de-energization of equipment. This type of machinery is related directly to the efficiency of the supply of electricity. Interrupting short circuits or overcurrent to maintain operation of other circuits is one of the most essential features of the switchgear. The switchgear is often used to allow a load to be fed by more than one power source. If you have a medium voltage directly coming into your mining facility, you most likely would need to have a medium voltage switchgear along with a step-down transformer. Medium voltage switchgear is normally installed in the facility's electrical rooms. The utility feed demarcation point in this case would then be right at the medium voltage switchgear. That is the location at which the medium voltage feed is terminated within the facility. If you have a medium voltage generator, it would also be connected to this. It is also the duty of the medium voltage switchgear to disconnect faults and to monitor the medium voltage power delivery. For example, when isolating a section for purposes such as routine maintenance. Medium voltage switchgear can be relatively complicated to spec, as it has a plethora of components such as meters, circuit breakers, contactors, fuses, surge arresters, PTs, CTs, and various relays, etc. You don't need to know all of the intricacies of these components, as usually the manufacturers, and I'm talking about the big ones, will already pick the best ones, and they can tell you whether or not it meets the standards of your local region. What you need, however, is to look at the following properties to see if it suits your needs. And these are shown in front of you right now, and we got 5, which is first of all, it's the rated voltage, which is the peak value of the voltage that the equipment will tolerate on an ongoing basis, and it is normally chosen to be marginally higher than the operating voltage. Then there is the current rating, which is the peak current value that the equipment will tolerate on an ongoing basis. Third, there will be the impulse withstand of voltage, which is an indicator of the device's insulation to tolerate overvoltage resulting from external faults, such as a lightning. Fourth, there is the power frequency withstand voltage, which is a measurement of the equipment's insulation strength to prevent overvoltage resulting from internal faults or switching. Lastly, there are the physical dimensions, and we need this to see what is the footprint of it and how can it be installed within our mining facility. Within the facility, you may also need to install low voltage switchgear as per your design if you require centralized protection and control of your low voltage equipment, or what I mean by that is your mining rigs. So the next components are the panel boards and the switchboards. Now, panel boards is a distribution board that helps split the electrical power supply into subsidiary circuits, supplying each circuit in a common enclosure with a safe fuse or a circuit breaker. Switchboards, on the other hand, is a device that directs electricity to many smaller regions of use from one or more sources of supply. It is an assembly of one or more panels, and each containing switches that allow for the redirection of electricity. Now, a switchboard function is to allow for further diffusion of the current supplied to the switchboard into smaller currents, and to provide switching, current safety, and possibly metering for these different currents. Switchboards will typically distribute power to transformers, panel boards, control equipment, and to individual system loads. Now, for a power distribution unit, or short form as PDU, is a multi-output system designed to distribute electrical power, especially to computer cabinets and networking devices. So in this case, it is used to support for our rig cabinets. These are typically used in data centers, but we are going to use it for large-scale mining farms as well. And just think of this as just very large power strips that we use to supply power to our racks and cabinets. Lastly, I want to talk about a very important component in the electrical system for our mining farm, which is the uninterruptible power supply, or short form as the UPS. This is an electrical device that provides emergency power to a load, in this case our mining rigs, when the input power source or main power fails. The UPS systems are designed to only function for a finite period of time to provide emergency power, typically in minutes. Usually, they're defined to maintain the operation of the equipment just before any other emergency power source can be kicked in, so that you can restore to normal usage. So in this case, another power source that can be kicked in can be in the form of, let's say, a backup generator. One of the most important things when looking at the UPS is its hold time, and it is characterized as the amount of time from the lack of main power until the batteries are no longer able to provide the power needed to keep the load power within the specifications. Now, if you're not considering any backup power solution, for example, you're not going to utilize or install a backup generator, then a UPS should be spec'd with a holding time enough for the mining rigs to gracefully shut down. And when the UPS kicks in, you can configure it to have a loud beep, and some can even have sending out a remote signals which prompts you as the user or for your team to shut down all of your mining rigs before the actual power failure kicks in, so that you could prevent any permanent damage that can be done to your mining rigs due to the power outage. There are only a handful of requirements of the facility design that will affect your long-term cost, availability of system, and overall success, more so than how you define your power requirements. For example, you will run out of power before you have filled your space with mining rigs if you underspecify the amount of power you need. On the other hand, if you overspecify your energy requirements, you will pay more for your space than you need. You will need to consider how much power the overall facility can consume, whether you are constructing your own mining facility or just leasing a co-location space. In such a case, you can create a spreadsheet and plug in a nameplate maximum power from the spreadsheet for each component that will be in your mining facility and just sum them up. If you don't trust in the specs of the nameplate to be realistic in your situation, and let's be honest, in most cases it won't, you can take real measurements with power meters of the component and multiply by the quantity that you will deploy. Now, it is not too difficult to get current power consumption, but projecting what you need for the future will be the harder part. With this, you will need to provide an estimate that over a reasonable time period, how much extra mining rigs can you imagine being deployed, and how much power each of these mining rigs can consume. The tricky thing is that mining rigs actually would have different power consumptions, so it's actually a bit harder to gauge it, but you can actually just ballpark it based on what you have in your current model of mining rigs. Now lastly, I wanted to talk about power billing methods. For billing, there are many different ways that your facility can be charged. The way you're paying for electricity has a profound effect on your operating cost. The cost of electricity, in my opinion, greatly outweighs the other factors, including the cost of space itself. The two common ones, the two common billing methods are what we call the circuit-based billing method and the meter usage billing method. Let us start with the circuit-based. You are charged a fixed price for power circuit in a circuit-based billing environment, no matter how much electricity you actually use from that circuit. Basically, at all times, they charge you for 100% usage of the circuit, whether you consume the maximum amount of power permitted by electrical code or not. Even with mining rigs typically running at 100% most, if not all the time, I would still be careful in signing for this type of contract. So I would recommend you to instead look at the second type of the billing method, which is the more common type, the meter usage billing. Now there are generally two components of this type of billing, which is the actual cost and the upcharge. While the actual cost is explanatory, which is the cost of power that you consume in the facility, the second component, the upcharge, would appear if you are co-leasing a space, in which the monthly charges for the auxiliary shared power consumption, such as cooling and or security system, would go into this upcharge. The upcharge may be distributed proportionally by the percentage of space your facility takes up in relation to the entire complex. Now, there's also another thing with the upcharge, and is that if you go above a certain threshold of your electricity usage, you might actually need to pay a premium as well, and that also goes into your upcharge portion of that electrical billing. The intense mining activity from your rigs will result in the generation of immense heat as your rigs consume electricity and while mining your bitcoins. The rigs itself has a small working temperature range, which ensures that the heat cannot be allowed to build up in the environment, and that the heat must be extracted in order to ensure optimal operation. Failure to do this correctly could lead to the rigs crashing, and in some extreme cases, there might be permanent damage to the rigs as well. This video is intended to include a basic understanding of cooling, the principles behind it, the different forms of cooling environments, construction architectures for your Bitcoin mining farm. This will allow you to better identify the specifications that you need for cooling at your mining facility. So, let's get started. The majority of the power used by your mining rigs is converted into heat, as I've already mentioned. It is necessary to eliminate this heat, otherwise the mining equipment temperature would increase to the point of a failure. Now, the second law of thermodynamics in physics states that the heat moves from an object at a higher temperature to an object at a lower temperature. And we can utilize this law of thermodynamics in our favor. Through running a current of a cool air over the circuitry, heat can be eliminated from the mining rigs. Of course, the net effect of this cooling is that cool air is sucked into the rigs, and hot air from these very same rigs will be going to be exhausted out from it. The aim of the cooling environment for the mining farm is to transform the hot air that is exhausted from these rigs into cold air, which we can use a method called refrigeration to accomplish. Refrigeration makes it possible to successfully pump the heat energy that gets generated from the mining rigs to somewhere outside of that space, particularly where it is cooler than the temperature inside the space where these rigs are situated. The cooling equipment used in a Bitcoin mining farm varies from other types of systems used for residential or office spaces. These cooling equipment are designed to have much more precise environmental regulation and to regulate both the room's temperature and humidity. There are 5 major components that you will see in the mining facility's cooling system as shown in front of you right now. Let's go over these one by one. So let's start off with air handler or conditioner. Although there may be differences between air handler and air conditioner, in all cases, these are just cooling coils where air passes through and that the heat from this air gets extracted into the cooling fluid that are inside these coils. Next, it is the heat exchanger. Typically, the heat exchanger is mounted on the building roof or some other location outside of the facility itself. Depending on the type of cooling system that is deployed in your mining facility, numerous forms of heat exchanger can be used. Then there is the expansion valve. The expansion valve eliminates pressure from the liquid coolant to allow the evaporator to extend or shift its state from a liquid to a vapor. Although the liquid refrigerant exiting the expansion valve is cold, the high-pressure liquid refrigerant entering the expansion valve will be hot. Inside the valve, the orifice does not expel heat, but rather it lowers the pressure. Then there is the pump, which is mostly for moving the cooling fluid throughout the system. Lastly, it is the compressor, which is used to cool the liquid with a condenser. The compressor takes the coolant that has been expanded into a gas, compresses it back into a liquid, and at the same time increasing its temperature, of which it is then sent to the condenser. Since in the beginning of this video I've just mentioned the concept of refrigeration, let us talk about the refrigeration cycle. A closed loop of evaporation, pressure change, condensation, and the flow control of the refrigerant fluid is what we call the refrigeration cycle, and it is shown in front of you right now. As you can see, it consists of 4 stages, namely the evaporation, compression, condensation, and expansion. So let us briefly go over each of these stages. Evaporation is the first phase, at which the heat is derived by the return of hot air from the space where your mining rigs are. The hot air from the space is then blown through the evaporation coil. The evaporation coil has cold liquid running into it, which, by extracting the heat from the airflow through the coil, turns this liquid into gas. The conversion to gas can happen at this relatively low temperature for a state change due to the pressure being maintained within. The second stage is the compression. The vaporized refrigerant gas, still relatively cold, is then pulled through a compressor that compresses the gas into a high-pressure liquid. The method of compressing the gas into a liquid allows the liquid to increase in temperature, resulting in a hot liquid that is then transported to the outside environment where the heat is extracted. The pumping the hot air into a condenser coil to extract the heat is what we have in the third step in the cycle, or what we call the condensation stage. Then we move on to the last stage of our cycle, which is the evaporation. So even that the condenser coil has cooled the refrigeration somewhat in the condensation stage by extracting the heat, as it exits the coil, it is still a relatively hot vapor, and too hot to directly cool the mining farm. The refrigerant is then piped through a system called an expansion valve. And the expansion valve helps significantly decrease the pressure of the liquid, which in turn lowers its temperature. The resulting lower pressure liquid then reaches the evaporation coil again, initiating the cooling cycle at the evaporation stage, and thus it goes on and on and on. Now that we have reviewed the refrigerant cycle, let us now look at the cooling architecture. There are a variety of different architecture or configurations that are available for mining facilities, and this mainly differs depending on the site of which you will be building your farm. However, it is important to note that the cooling architecture of the mining facility is not something that can substantially drive the site selection process, unless the site is going to be a world-class big mining facility, which the probability of that applies to your case would be pretty slim. It is important that you have a clear understanding of how your mining equipment is cooled by the various architecture. The cooling architecture differences rely on differences in how heat is shared between the facility's interior with the outside environment. In the most simple configuration, we will use 2 heat exchangers, where the first one removes the heat from the air and transfer it to the refrigerant, and the second heat exchanger removes the heat from the refrigerant and transfer back to the space of the mining rigs while the heat is transferred to the outside air. The 3 most common architectures are the air-cooled, the water-cooled, and the glycol-cooled. In most crypto mining farms, you can see that the air-cooled architecture is mostly the standard architecture to use. In its most simplest form, the mining farm will only be using a computer room air conditioner comprising most of the components of the cooling cycle, which includes the compressor, evaporation coil, and the expansion valve, along with a condenser unit outside the building. It is necessary to remember that other components such as pumps, valves, and filters may be needed in the system. Another typical architecture of the cooling system puts an additional major component between the internal air cooling units and external heat exchangers that transfer the heat into the outside air around them. This component is referred to as a chiller. With this system, there would be a private cooling loop of chilled water that is cooled to a temperature of about 8 to 18 degrees Celsius that services the facility. The cooling loop would then transport the water to the chiller where heat is drained from it, and from the chiller, the heat exchanger transfers the heat to a second refrigerant loop. In comparison to using an air conditioner in the air-cooled architecture, the cooling unit in this architecture is usually an air handler instead. They have the same general function, however. They do it quite differently. The cooled water in an air handler is moved through a coil, and to get the heat withdrawn, the cooled water is heated and then pumped back to the chiller. As in the case in what you see in front of you right now, the chiller is just a heat exchanger of the facility and external refrigerant loop where the main goal is to transform the heat to the air outside. The third common type is the glycol-cooled architecture. The glycol-cooled architecture differs from the air-cooled configuration by replacing the condensing coil with a heat exchanger that moves the heat into a secondary loop away from the cooling cycle that then goes to a dry cooler outside the building that transfers the heat to the ambient air. Glycol is used because it can retain more heat than the same volume of water or air. This combination decreases the function size and the pipe size necessary for the heat to be transferred out of the facility. While the key equipment used to provide cooling within a crypto mining facility, you quite possibly have no control. Especially if you are co-leasing or sharing the facility with some other businesses, you can still determine how the air is being distributed within your facility space. In any air delivery design, there would be a variety of factors that you need to be considered. The mixing of the hot and cold air streams would be the toughest consideration in air distribution design. Nevertheless, containment and the location of the cooling units will be crucial to your air delivery architecture performance. Let us now go over the common mechanisms in air distribution. There are 5 most common mechanisms for air distribution, and they are the flooded air supply, contained air supply, contained return, targeted return, and the targeted air supply. Let us start with the flooded air supply. A flooded air supply system is basically one where the flow of hot and cold air inside the facility is not controlled. There is considerable mixing of hot and cold air, leading to a cooling environment that is very inefficient. Now, for the contained air supply, both the cold and hot air are enclosed to eliminate mixing between the air of different temperatures. One way to do this is to feed the cold air through the ductwork or under the floor, if it is a raised floor system where the mining rigs are in rows of enclosed environment. The hot air is then expelled to the room environment. The third type, contained return, is the opposite of contained air supply, where the hot air is instead exhausted to the ductwork or the bottom flooring, and the cold air is flooded into the equipment room. As for the last two, targeted supply and target return architecture, you will still utilize either the overhead ductwork or the raised floor to direct either the cold or hot air. However, in this case, it would not be directed into or out of an enclosed environment. The answer of which architecture to choose is relatively straightforward. That is, where the more control you put over the air movement, the higher the solution's cost will be. So you will always need to balance what is more important. whether or not the flow of air or the cost that you will pay. If you're thinking about this for a long-term approach for a large-scale mining farm, I would recommend at least a target supply architecture just so it has more control and efficient air circulating environment. For temperature and humidity, you need to first consider the temperature and humidity limitations that your site imposes in order to resolve the whole temperature and humidity problems. You also need to determine the temperature and humidity levels that you need to operate your mining rigs. Therefore, the operating limits of your rigs in terms of temperature and humidity needs to be guaranteed that it will not be reached when operating in your facility. I would recommend that at the intake vents of your rigs, you should install sensors measuring the supply air temperature. You should also set up multiple alerts that will alert you on your mobile device or something as to whether the temperature or humidity raises or decreases to a point where the activity of the mining rigs are at risk. Furthermore, the environment that the rigs are in will start warming up in the event of a cooling malfunction, leading to a steady increase in intake temperature. Before you have hit the limits of the mining rigs, you would want the starting point of the temperature rise to be low enough to allow you some time to get the cooling back online before any real damages can be done to your mining rigs. It is obviously one of the most critical factors in a Bitcoin mining farm to keep the mining rigs cooled. That said, there's a difference between the need for power and the need for the integrity of the cooling system. A failure of the cooling environment for a few minutes is not a disastrous occurrence, but power should not be lost to the rigs for even a fraction of a second. The explanation for this is that in a mining farm facility, there is a comparatively large thermal mass that creates a time buffer until the temperature increases to the extent that the mining rigs are going to be at risk. As such, cooling equipment does not necessarily need to be connected to the UPS, but it does need to be tied to the backup generation if there is one. As for redundancy of the equipment, I would recommend an N+1 redundancy model. However, if you do not require a continual operation, this really does not matter, as when it fails and it alerts you. You should have enough time to shut down these rigs before the heat buildup can do any permanent damage to your equipment. I will go over redundancy further into this course. Lastly, I would like to go over some bits and pieces of things that you can do to improve the cooling architecture. And they are the blanking plates, the brush plates, extra wide cabinets, and the routing of cables. Blanking plates should be installed in any unused positions in racks and enclosures of which the rigs are mounted, because this can actually greatly help the airflow control. These can be easily installed and they are not expensive, so be sure to consider installing blanking plates on any unused positions. Now, if you need to reroute cables from the front of to the back of the cabinets and vice versa, consider to install brush plates for the reroute of these cables. Now, these are similar to blanking plates, where it actually helps the airflow by blocking the air from going from the front to the back of the cabinet uncontrolled. However, in the case, it has brushes instead, so that you can have cables to go in and out of these plates, but you got brushes to prevent or limit the airflow in between. The last two, the extra wide cabinets and the route of cables or rerouting of cables, is basically the same thing, in which the main objective is to not impede airflow and to maximize the architecture, the cooling air architecture that you will be using. Besides your mining rigs, the second most important asset that you will have in your mining facility are your cables. Cables in your facility affects a lot of how you design your mining facility, and cables might be the asset that, if not spec'd or maintained appropriately would lead to the most failures within your mining farm. In this video, I am going to talk about cabling within your mining facility. The very first thing to do is to consider which standard philosophy you want to stick to in the design or procurement of a cabling scheme. There are three paths that you can follow, and they are: first, defining the cable grade that you need and just have the installer sort it out. The second path is to rely on the cable manufacturer to know what is best for your needs. And finally, the third path is to refer to one or combination of industry standards. Now, leaving the cable specs and the system design entirely in the hands of an installer is a very dangerous choice and can only be contemplated by those aiming for just getting the job done at the lowest price possible. However, do not ignore the continuing cost of ownership, as you may pay a huge price down the road in cable failures if they are not spec appropriately. Now, a lot of companies, including utility companies, often rely on the cable big brands to have them tell you what cables to use and what cabling system should be in place. Now, the reputable manufacturing companies do have experts where they know the industry standards inside and out, but their willingness to help you will depend on whether or not you are considered a big client or if there will be any continuing businesses with them. Now, with Bitcoin mining facilities, it will be hard for them to be enthusiastic in lending their expertise to you. Also, it is more common than not that cable companies go into a lot of mergers and acquisitions. So often than not, you will not stick with a particular cable manufacturer when you need to do cable replacement. Not to also mention that although they have a general industry knowledge, they don't have specific knowledge of what you need in your particular mining facility. So it is best to have knowledge on your own cable design. In our mining facilities, essentially there are two types of cables that you need to be aware of. One being the power cabling and the other one being the telecommunication cabling for communication on your rigs, in which we refer these as data cables. As such, you will need to refer to a set of standards for both power cables and telecommunication or data cables for your particular region. Now, if you are in the United States, for telecommunication or data cables, you can refer to a standard called TIA 568, which focuses on telecommunication cables in commercial buildings. As for the electrical portion, and I'm referring to United States again, you can refer to the NFPA 70, or what we also know as the National Electrical Code. Please don't refer to these standards if you are not building your mining facility or your mining farm in the United States, as the requirements are different from region to region. Nevertheless, you will need to refer to the standards in your particular region for commercial building cables for both electrical and telecommunications for your facility build. Let us start with the concept of structured cabling for telecommunication cables. Structured cabling is a cable infrastructure for voice and data communication applications. Structured cabling provides one point of origin for the whole system. Other units are connected to the system when needed. This helps you to have a single hub where any improvements to the system and repairs can take place. If the telecommunication infrastructure in your mining farm is badly built or poorly constructed, it can lead to downtime and unnecessary cost for maintenance. Intermittent failures are some of the most frequent problems with bad infrastructure design and implementation. The telecommunication cable system contains essentially two major building blocks, that is, the cable itself and the connecting hardware. For the cables, the most important parameter is its characteristic impedance, and these are split into categories as stated in the ISO standards. Without going into any deeper, you only need to know that the only ones that you need is category 6 or 7 cables, with the most prominent being 100 watt characteristic impedance of these categories. Now, if you want to learn more about this, you should get a copy of ISO 11801 for more information. Now, most of your cables of your facility will be residing indoors, but there will be cables residing outdoors as well, such as from the telecommunication demarcation point, which is usually off from a pedestal, to your building. These cables will need further requirements as they need to be outdoor rated as well. On top of the requirements of indoor cables, you will also need the cable to be water resistant, and in the case where the cable will be exposed to sunlight, it needs to be UV resistant as well. If it is buried underground without ducts to protect it, then you will need to specify outdoor cables with armoring, such as external galvanized steel wire and or corrugated steel tape. The other major component is the connecting hardware, where the most common ones are either 8-pin modular connector plugs and sockets, and the other type is the insulation displacement connectors, also known as the IDCs. Cables in the end will be terminated in what we call a patch panel or patch bay, which is situated on the racks or cabinets of where your mining rigs are for your rigs to connect to. Some more expensive patch panels has an added level of intelligence by displaying connectivity information as well. In the end, the connections will get rerouted into the router and then through the modem to be connected to the internet. As briefly mentioned in the other videos, how power cabling works really depends on your region's electric code. So what I'm going to talk about is going to be very generic. For example, in the United States, we will refer to NFPA 70 and NEC Article 300 and 310 for wiring methods of the mining farm. As general methods, we usually have two choices: the raceway conductor method and the busway method. The raceway conductor method utilizes conduits or tubing with insulated phase, neutral, and ground conductor, where each raceway and conductor is field fabricated. The advantage of using raceways is that changes can be made comparatively easily, but it is limited to the number of bends before you need a junction or a pull box. The second method is called the busway method, which is a metal enclosed raceway with factory mounted bus bars. The advantages for using this method includes being a bit more compact and less use of space, but it is also more costly and more susceptible to water leaks as well as potentially high short circuit current. For both the data and electrical cables, PVC or polyvinyl chloride and PE, or so-called the polyethylene, are the most common insulating jacket being used. These jackets are combustible and have a probability for propagation of a fire, and this is more prominent when the cables are bundled together. Now, fire protection of the cables in your mining farm is really not a must-have, but it's good to keep it in the back of your mind when you are choosing cables for your mining facility. With both types of cables, there are various fire retardant coatings available depending by the manufacturer that prevents fire propagation along the cable. I would also recommend to look at low flammability, zero halogen material options. The reason for this is that the halogens in the cable, although a flame retardant itself, releases toxic fumes when combusted, which not only cause harm to cable, but it will also have damaging effect on circuit boards, which also means that it may damage other equipment that may not be directly affected by the fire itself. And when I mean by other equipment, I mean your mining rigs. If you are interested in looking at this topic further, I would advise you in looking at IEC 6332, which lists out the test on cables under fire conditions. One area within your facility that you need to pay extra attention to is the plenum space, which is the space that is used for our air circulation system. This area carries airflow between the interior of the facility and the outside environment, which makes fire easily spread in this area. This space is usually located between the structural and suspended ceiling, as well as under the raised floor. Now, if there's any place where I would recommend, if you want to have extra fire protected cables, you should install it in these areas, as these are what we would consider as high risk areas of catching fire and spreading fire. As a general rule, there needs to have a defined protected route that will protect cables from the external environment. You should not have cable installers to randomly route the cables by only giving them the need of installing cables from point A to point B. Now, some of the consideration that we need to look at include the following as shown in front of you, and we got 4, which is bends, bundle size, intersecting cables, and the separation of cables. Now, with bends, when designing the pathway or routes for your cables, you need to make sure that any of the bends are not less than the bending radius set by the manufacturer. And if the bends are too tight, the cable may become damaged. As for the bundle size, there is no limit as to how many cables can you bundle at the same time, but do keep in mind that the bigger the cable bundle, the harder it is to manage and maneuver. So put that in the back of your mind when imagining you're pulling cables. The higher your bundles, the number of cables that you're in your bundle, the harder it is to be pulled. Now, as for intersecting cables, in the case that if you need to have your power cables intersecting with the data cables, you need to make sure that it is done at 90 degrees. And this is because we want to minimize interference caused by these two cables. As for separation of cables, if possible, we should separate the parallel runs of power cables and data cables by 20 centimeters. Now, it is not a must. This is just a recommendation. If you are interested in further readings on these, there are numerous standards that you can reference it from. I recommend in starting with the ISO 18010, which is titled Information Technology, Pathways and Spaces for Customer Premises Cabling, as well as IEC 60364, which is titled The Electrical Installations for Buildings, for more details. Lastly, let us talk about grounding. For safety reasons, all exposed conducting surfaces must be attached to an earth point. This is to guarantee that any accidental completion of the circuit due to touching of the conducting surface would create a big enough fault current that a fuse or a circuit breaker would blow. If these exposed circuits or surfaces are not attached to an earth point, or in other words, left floating, the live voltage would be retained until someone or something makes contact with it, at which point they would form the conductive path to earth. The goal of having electrical bonding system in the mining facility are due to 2 main reasons. And the first one being to have protection against electrical hazards, like the one that I mentioned before, being forming a path or conductive path to earth, and 2 being using it as a signal reference for some equipment. Now, point 1 and 2 are actually referring to 2 different types of earth connections. Now, of course, the first point refers to protective earth, which is to prevent exposed conductive surfaces from carrying fault currents. But the second point actually refers to what we call a functioning earth, which is to provide a 0-volt reference point for some equipment to function appropriately. Equipotential bonding is a mechanism which is used to maintain a series of electrical equipment to achieve a relatively similar electric potential. This means that we will connect anything metallic that isn't part of a current carrying circuit to everything else before being connected to Earth. The main idea behind this is that current flows in a voltage or potential difference. So if there is no potential difference, or what we call equipotential, no current would flow in between these. Bonding should not only be to just connecting the equipment, but also to service pipes, ducting, heating, and the conditioning or air conditioning system. You connect all of these components through something called a bonding conductor, which the size of it will depend on the anticipated fault current your facility might have. If you're concerned with electrical safety, meaning that during an electrical fault, it might cause potential injuries while you were tinkering with the equipment, which it is, just so you know, very unlikely given the amount of current and voltage level that it will be at your site. But nevertheless, you can still use electrically rated PPE such as electrically rated boots and gloves to touch the equipment if you have a concern of electrical fault and electrical safety. The thing is, speccing, designing, and installing cables is a very complex process. I highly recommend you to not do this on your own and hire a certified licensed contractor to do this for you instead. The thing is, I have only touched the surface of this subject, and you will need years of schooling and apprenticeship to get this correct. Not only that, to acquire the relevant business and operation permit for your mining farm, depending on the region that you are in, will actually require inspectors to sign off on your site that it satisfies all requirements of the local electrical and building code. And any non-conformance may require you to redesign and rebuild of your facility before you can start mining your first coin. So you will not save any money by doing it all on your own, unless of course you are an experienced person already in doing electrical and network connections for various buildings with complex IT infrastructure. Then I would say go for it. But still, I think the best way is to go for a reputable contractor to do this work. And I'm not saying just for cabling. I'm also saying the other things that I have talked about, which is the power portion, the cooling portion, the construction portion of your site. As you have probably figured out already, the information that I have given you is actually more or less catered towards you hiring the contractor and to be effectively communicating, not to actually design and build it your own. So by watching the videos within this course, you should have enough information to express what you need for the infrastructure builds on your mining site. Now, if you need additional details or any other materials in order to communicate to your contractors or your builders effectively, then I would consider reading the materials that I recommended throughout this course for more information. But nonetheless, I am not here to teach you to build this from scratch by yourself. But what I'm here to do is to make you to be competent enough, to be confident enough to make sure that you have the tools that you need to communicate effectively to your contractors and your builders to build the state-of-the-art mining facility that you need for your mining operation. In this video, I would like to touch base on the security that is needed for your mining farm facility. First, let us talk about the surroundings. Now, I remember I've gone over this briefly in a previous video, especially look at the location and the building. It essentially all comes down to what your neighbors are and whether if there are any potential dangers due to the surroundings. Now, when you are considering the neighbors of our mining farms, of course we do not want criminals as our neighbors, but my main point is to actually avoid tenants that might potentially be a hazard to your operation. For example, you should avoid establishing your operation in close proximity with a business that manufactures explosives or other things that might cause explosion or fire hazard. Also, you should not choose places where it may be a target of potential attacks, such as military contractors, pharmaceuticals, or financial services. Also, you should avoid places where there might be susceptible to vehicular impacts. There are many cases where the drivers were heavily impaired and lost control of the car, in which it will then crash and cause huge damage to facilities in general. I'm not saying that it will happen or it has a high probability of happening, but I mean, if possible, try to minimize the hazard as close to zero as possible. So to avoid this, make sure to avoid choosing locations that are close to high traffic roads. Remember, to avoid being in a situation of danger is the best type of security for your mining farm. Now, let us look at some of the security consideration for the building itself. And we got three huge consideration, which is protection, parking, and walls and opening. Now, with walls and openings, if you are co-leasing the building complex with other businesses, ideally, your space should not have walls that are facing a roadway or in a way that a vehicle can ram through the wall. Another most ideal case would be to have a space with no windows and kept the number of exits or entrances to a bare minimum. Again, this is to minimize any security risk by minimizing the contact points of which accidents can happen. Also, we should avoid to use any markings or any indication in the exterior building, as we don't need to tell the world that we have expensive mining rigs that are inside for thieves to grab and to build their own mining facility, for example. Now, for parking, we should avoid having parking spots that are against the building or to the walls of the facility. And again, this is to minimize the contact points of which accidents can happen. As for protection, in the case that you have walls and openings that are exposed and you can't really do anything about that, then you may need to add exterior protection such as fences, jersey, or concrete barriers, and a gate for your area. You have a lot of expensive equipment in the mining farm, and not only that, these expensive equipment, and namely I'm referring to your mining rigs, are highly sought after, as it allows someone to easily generate the hottest commodity in the world right now, which are bitcoins and other types of cryptocurrency. As such, you will need 24/7 security personnel to monitor the site and keep it secure. The security personnel or team should take walks around the facility according to a prescribed timetable. The intention of this is to take note of something that could go wrong, such as a door wedged open, boxes or equipment in the aisle, or spotting suspicious people, etc., as well as making sure that these items are taken care of, and also they would notify you when such events happened. Deploying surveillance cameras inside and outside of the facility is a must, as it not only records the events that are happening, it also deters to a certain degree of theft and vandalism as well. Security cameras should be installed at locations that maximize visibility and should have redundancy, so that if one camera is down, there should be another one at a different angle that can see what happened. When deploying security cameras, the two questions that you need to consider are, first of all, What does the security department do, both internally and externally, regarding the site surveillance feeds? And the second question being, how many cameras are there and where are they going to be placed? Surveillance is usually a reactive activity. Even the cameras on the video monitors are rarely actively watched. Everything is still going to be recorded so that when something disappears or a bad event occurs, there is going to be a record. Now, in order to solve a problem or an incident, these camera recording will going to be very valuable and useful. So in a sense, one of the most important things that you need to consider also is you need to determine how long the video recordings should be kept. My recommendation would be usually 3 to 6 months would be fine. As you know, more than that, you probably are not going to revisit those for particular incidents. But whatever that you choose as to the duration of which you keep the recordings, you should standardize this number. So you should actually use it as, put it in the policy of which you are going to maintain all of the feeds in that particular time duration, and there should be no negotiation on that. So everything should be kept at that particular duration. Now, lastly, for security, I want to touch base about security access. For security access, I would recommend card readers or the badge access system, where access is only given to a very specific group of individuals as well as the security personnel or team. There should also be logs as to the timestamp of each access and by whom. So with a badge access system or card readers, a lot of systems have already automated logging if you're utilizing these. Now, of course, if you're not owning a large-scale mining farm, you may only want the normal lock and key. But the level of security would be very low, and considering that you have expensive mining rigs in the facility, I believe it is worth your investment to get better security mechanism. Now, on the more extreme end, you can also consider the use of biometric scanning, which identifies you by your biometrics such as fingerprints or retina scan. Now, of course, this is a much better method than the electronic locks, but the cost and complexity of implementation on these may be too much for mining farms in general. So, in a sense, I would still just recommend using just the card readers or the badge access system for your mining facility. Organizing the mining farm is highly recommended as it allows you to quickly execute some of your tasks such as troubleshooting and maintenance. In this video, I'm going to talk about how you should organize your mining farm so that it is easily maintainable and be ready for future growth. Let's face it, you are not going to buy all the rigs all at once. And to top it off, you will not going to use the same rigs during the entire lifetime of your mining farm. The newer mining rigs always will have faster hash rates than the old ones, which soon you may find your purchases be a waste of shelf space. For example, most if not all GPU miners now are rendered useless to mine Bitcoins, and now these are taken over by ASIC rigs. As the algorithms get more complex, the return that you get from your rigs will be lowered over time. This means that there will be a dynamic flow of mining rigs into and out of your mining farm. So, what is a good way to go about this? Well, the most intuitive thing to do is to group the rigs by the manufacturer, and if possible, fill the entire row of cabinets with the same year-end brand of rigs. That way, it will be easier to maintain and find, as now all of the same rigs are being grouped together. Now, this is good and all, but what about if one rig needs to be replaced? Well, if that is the case, I would first check how long ahead you intend to obsolete these line of rigs. As I mentioned before, you will need to get newer rigs as they would do things faster and the return of investment would fall as the mining gets harder. So if it is close to the time that you want to replace the entire lineup of these rig model, then you might need to balance between the loss of income during this period for the down rig and the volume discount, as well as the time and cost of just replacing one rig versus doing everything in bulk. If the lost revenue is not justified, then I would suggest to buy the mining rig model in which you intend to bulk replace this particular model with. That way, you will still have a uniform model lineup of rigs. Labeling is quite the most essential thing that you need to do when organizing your rigs. Even with clustering, due to mining rigs fail at different rates, you will still end up with mining rigs that are here and there. So proper labeling is the next step that we can do to keep your mining farm organized. First, you will need to establish a numbering system. What you do is really up to you, but I can give you an example. We can start with a 5-digit code for each mining unit. So I would use an alphabet letter in the leftmost digit to distinguish the row, then a numerical value for the cabinet number, then the next 2 digits is the rig number starting from 1, counting from the top. And the last digit represents what equipment it is. So R will be rig, E will be electric cable, D will be data cable, P is for panel board, etc. In this case, B508R will be referred to the mining rig in row B, 5th cabinet, 8th from the top. As I said, you can do the numbering whatever you please. After all, it is your farm. But whatever you do, I would like to advise you that your numbering scheme should be both consistent and comprehensive. With that in mind, you will also need to print labels and stick it on every single of your asset, including cables. Yes, cables needed too, so that you will know which cable is for which rig space. Particularly with cables, you will need to label it for both ends of the cable just for easy troubleshooting and replacement. Lastly, you will need to relabel with the same number for any of the components that are replaced. Note, we are labeling the placeholder, not the component, which means that just because we replace a cable, for instance, the cable's purpose is still support a particular rig at the same location. Lastly, you need to keep track of your asset. If you want to do it in the simplest manner, a spreadsheet would do. Now, since I mentioned using the spreadsheet, let's continue on with this example. If I want to keep track of the data in the spreadsheet, I would organize all of the assets into individual sheets, and in each sheet you will have the following, which is the ID number, which this is what you label your asset is, the model number, which is what the model of the asset, the install date, which is the date of installation, the last maintenance date, which is the last done maintenance, and make sure that this is not filled up when the asset is first installed or replaced. And the last category is notes, which is the log of maintenance. And this can be just short notes, just a little note form of what you spot during your maintenance process. Now, a cell in your spreadsheet can be multi-line, so you can actually put a lot of entries in there. Just make sure to delete all of these when you replace the asset, because that the maintenance logs would not apply to your new asset. Of course, you might want to do this in a different manner, such as using a database or capturing different information. Now, again, the choice is up to you, but I will urge you to be disciplined in maintaining the information. As for each things that are installed, maintained, replaced, it needs to be reflected in the spreadsheet or a database. After all, this is the blueprint of your farm, and it will help you tremendously in the long run in keeping track of the various equipment in your mining farm. Now, the future is quite unknown, as cryptocurrency in general is very volatile in nature, and regulations are increasing all over the world, and to top that off, it is actually getting harder and harder to mine. So what if you don't think the operation is profitable anymore? Well, if that is the case, you can decide pivoting your operation to suit other purposes, such as web or game server hosting. Although it will definitely not be as profitable, it will actually be much more consistent and predictable. You will definitely be not starting from scratch if you want to pivot, as the facility and the cable infrastructure is there already. And if you have GPU miners, those can be tweaked for these particular purposes as well. But buying used equipment for the pivot would not be that great of an investment, as you do not need powerful computers for server hosting in general. Heck, you can even diversify your operation portfolio by having a portion of your mining farm facility for server hosting. Then you can have a balance of consistency and not relying on a single source of income, which is Bitcoin mining. Now, if you want to pursue this, I would want to emphasize that you need to be exceptionally disciplined in keeping your spreadsheet or database updated to keep track of the types of assets that you have within your facility. Obviously, availability is an extremely significant element in the process of choosing the location. Perhaps the most important thing to bear in mind is that the greater availability specifically translated into higher cost. Since availability depends on redundancies and diversity in so many aspects of the architecture of a mining facility, the cost of constructing a super available environment is much higher than one with lower levels of availability. You may also need to consider how you or your business determines availability for your Bitcoin mining farm. So, what is unavailability? Is unavailability called when you have unexpected failures for more than a certain percentage of your rigs? Is it deemed unavailable for planned downtime that you need for scheduled maintenance? Or is it considered to be part of unavailability when the rigs don't perform as you want? Well, for the latter one, for this I mean it is the rigs are performing below the optimal hash rate that you desired or you assume that it would perform in. You need to know what availability that you defined and what availability your farm really requires. Bitcoin mining is actually not a critical operation, meaning aside from the lost income due to the rigs are down, does not have any other detrimental consequences. However, you need to keep in mind that this is lost revenue, which means a loss of income, and considered that you may have a relatively high fixed cost. This may eat a huge chunk of your profit margins. So what exactly do we need to do to maintain availability? Well, for a Bitcoin mining facility, the most important thing that we need to have it continuously available is our cooling and power infrastructure. These are crucial for the mining farm. It is not detrimental if we have 1 or even 10 mining rigs that are crapped out, but if we lose power, it means all of our mining rigs are not generating income. Cooling is even more crucial in that if cooling fails, the continuous generation of heat from the army of mining rigs that you have will eventually be so hot that it will cause permanent damage to the mining rigs itself. This may lead to your whole inventory of rigs with a shortened lifespan, which replacing 10 rigs might not be much, but replacing your entire arsenal of mining rigs due to cooling failure might lead to an end to your operation. As such, I would say the power and cooling infrastructure are considered to be critical infrastructure. Yes, the computer network is important as well, but there are a lot of options available when a failure occurs, since we don't really use much data. And options can include things such as using wireless instead of LAN on the rigs, or even use cellular if our main trunk is down. Again, not many data is being transmitted in mining farms, so in that case, I won't consider this to be the same critical importance as the other two. Again, it is really up to your discretion. Before going any further, I would like to take the opportunity in discussing about some redundancy terminology, as I will be using it later on in this video. Redundancy would often be specified in terms of the number of additional components required to operate whatever facility that it is referring to, whether or not it is a Bitcoin mining facility or a substation. It doesn't matter. If the specific component needed to operate fails, a redundant part should take over. We have different configuration of redundancies, and they are applied depending on the type of situation it is. So let us go over these situations. As you can see in front of you, there is n, n plus 1, 2n, 2n plus 1, and 2n plus 2. Now, n is the minimum number of components required to operate the environment. So in this case, it means that there's no redundancy. Now, as for n plus 1, it is an environment where the amount required to run the environment is applied with a single additional variable, with the option to turn the redundant component into operation as needed. As an example, a third UPS is added to a system that requires 2 UPS with the potential to take over for any of the 2 required UPS devices when one is down. Now, 2n is an entirely redundant set of components. Now, if we use that same UPS example, this means that you have 2 other UPS that acts in parallel along with a redundant set of hardware and cabling. This means that you only need 2 UPS, but now you actually have 4 running at the same time. As for 2n plus 1, it means that with the 2n that are already currently running, you have 1 UPS on each side ready to switch in to replace those 2 UPS. So in total, in this example, we're going to have 6 UPS. As for 2n plus 2, or the last case, you basically have an additional UPS to switch in for each of the UPS that are running. So now you would have 2n plus 2, which is 8 UPS. For the sake of most applications, I would say 2n and 2n plus 2 is way too much, especially with our application of a Bitcoin mining farm. Since cooling is tied with power as well, I would say power is the most critical part of the Bitcoin mining farm. To start, I highly recommend the use of UPS as the utmost requirement for protecting the mining rigs. An uninterruptible power supply or uninterruptible power source, or UPS, is a device that, when the input power source fails, it provides emergency power to a load, or the mining farm in this case. A UPS differs from an auxiliary or emergency power source, or what we call backup generator, in that by providing energy contained in batteries, supercapacitors, or in flywheels, it can provide nearly instantaneous protection from input interruptions. Most uninterruptible power sources have very limited short supply of its lifetime, of only, let's say, a few minutes. Yet this few minutes is enough to launch a standby power source or shut down all of your rigs safely and properly. A UPS is usually used in situations that have significant operations that might result in a huge business interruption or data loss if there is an accidental power disruption. The size of UPS units ranges from protecting a single device to massive units that can support an entire facility, including an entire Bitcoin mining facility. Heck, some UPS are large enough that even could supply an entire data center. When the input power source fails, the primary function of any UPS is to provide short-term power. However, most UPS units are also capable of correcting typical problems and issues such as surges, voltage drops, voltage sag, noise, and harmonic distortion. In this case, I would recommend to have a redundancy of n+1 for UPS so that if the UPS is down, another one will automatically switch over. Making sure that the UPS is large enough to support the entire mining farm though. However, UPS only fixes the disruption that lasts in minutes, but not if there are sustainable outages that last for hours or days. One option that we can have is to have a backup generator which kick in when outages occur. You should have enough fuel for a few days or enough for you to be confident that the utility companies can amend the outage. If you have enough investment money, you can go even further in creating a cogeneration facility within your mining farm where you generate power for your mining farm to consume, and any additional capacity can sell back to the grid. You can also have heat recovery systems so that you can recover the heat produced for your cooling system. This can in turn, if designed properly, provide you with redundancy for both your power and cooling needs. Of course, such designs are complex and it falls way outside of this course. If you have enough money, I recommend you to get a quote from a competent engineering firm that is specialized in cogeneration design if you are very interested in creating such type of facilities to co-support your mining farm. However, do take note that even providing you with a quote would probably have a cost associated with it as well. In the last video of this course, I wanted to talk about the documentation and monitoring techniques that you can use to keep track of the performance of your mining operation and to see what areas that need improvements. Mining farms are not only complex, but also dynamic and need to be flexible as new rigs are installed and older rigs are going to get withdrawn from the site. As mentioned previously, in creating a spreadsheet or database to keep track of your assets, the more facts you have about your mining farm, the less unknowns that may create unanticipated issues or hiccups in your operation. And not only assets, you should also keep note of the events that happen within the facility, as well as the actions that you have taken. That way, it will allow you to troubleshoot things faster if in the future something similar happens again. For example, if a power outage has occurred and backup power did not kick in, you should record the time and date, how long did the outage occur, what causes the outage, as well as what should be done to prevent this from happening again. A map of the facility is one of the most important records to provide in a crypto mining farm. A map or floor plan at the very least should display clearances, cabinet positions, major equipment placement, and the mining farm's numbering scheme. This knowledge is valuable when allocating space for new mining rigs and important for planning future expansions. More comprehensive floor plans will also display the various styles and numbers of data ports and electrical receptacles that terminate at each cabinet position, as well as the exact routes that cabling and electrical conduits take inside the plenum space. These details are particularly useful when preparing to install or replace new mining rigs. Since the information is accessible without needing someone to physically access the area, having a facility floor plan helps you in planning future operation growth without being physically there. Not only that, it is much easier to communicate what you want to do and keep a record of the changes that you are implementing in your mining farm. So, how can you start creating a floor plan? Well, when you are hiring a contractor to build or repurpose the facility for mining purposes, be sure to insist to have a completed as-built drawings of the facility. When you hire contractors doing the electrical and data cable install or the power and cooling, etc., be sure to have them complete as-built drawings as well. Now, you should have most of the things on the draft floor plan already based on these as-built drawings beside your own numbering system. So basically, the contractors that you hire should already be completing most of the work for you in developing of this floor plan. With the spreadsheet or database that I have recommended you to create, you should have a fair amount of up-to-date knowledge of your rig inventory. And as I said earlier, the more detailed that you record, the better. What I also want to talk about regarding inventory is of your spare parts. For example, when a mining rig fails, you may replace it with a rig of the same model. But what happens with the old failed rig then? If it is within warranty, the decision can be really easy because you could just send it back either for repair or they would just give you a new rig. But without warranty, this rig, you basically just have to write it off and will be going to the landfill. But not everything fails within this rig, so it would be an utter waste to just dump it into the landfill. So instead, I would suggest you to get the rig for parts that can be used in your other mining rigs should failure happens in the future. When that is the case, I would suggest to dedicate a space in your facility to store parts and keep track of the inventory of these parts with details such as part number and the model number of the equipment that this is for. That way, you will know whether or not you have the parts for a quick fix of your equipment without physically checking each individual part that is spread everywhere in your facility. Monitoring. In the previous security video, we have talked about the use of security cameras for monitoring the facility premise. Well, this is not the only monitoring mechanism that we can use. Aside from video feeds, we should also gather other types of information to get a general sense of the operating environments of the facility. Here, I wanted to talk about 3 types of sensors that you can use for your mining farm facility, and they are the temperature and the humidity sensors as well as the amp meter. An important piece of information that you will need regarding with the farming facility is how hot or cold it is. A malfunctioning air handler or air conditioner, or airflow concerns, or hotspots forming due to elevated mining equipment density at a certain cabinet position can all be observed by measuring the room temperature. The temperature sensors installed within your mining facility air handlers is one component that can provide you with some of this detail. However, these are close to a cold air source, so they may not give a good indication of the entire situation of the facility. You should also install ambient temperature sensors as well to monitor the temperature of the entire room in this case. These sensors should be plugged into your network such that they can send the information to you remotely to give you real-time updates of temperature changes. The same ambient temperature sensors should also be equipped with humidity measuring capability as well. At least, I would suggest you to get sensors that measures both. Too much moisture in the air will cause accelerated corrosion to your equipment, and too dry may cause static electricity problems. However, don't worry too much about this, as we only need to monitor extreme conditions in the case of humidity. The third type of sensors that I would recommend is the amp meters that can be installed in the power strips of your rack or cabinets. These meters displays the electric load that is put on them. Sometimes cabinets may be limited not just by the amount of space, but also the amount of power it consumes as well. as different mining rigs consume different levels of power and there will be upgrades and replacement of rigs over time. It is a good practice to keep check if you are overloading the circuit or not due to your new power-hungry mining rigs. Some of these sensors also have remote power cycling capability, and it may be useful if you need to do a reset on some of the rigs if it gets stuck. The last topic that I want to touch base on is metrics. Metrics are very important in seeing where your business stands, how well your operation is performing, as well as how you can make it perform more efficiently. You should assign the metric to be in a span of a standardized period, such as monthly or quarterly. It doesn't matter, but whatever you do, it needs to be standardized, meaning that it should be consistent. The 6 metrics that I want to introduce you to are the incident logs, the availability percentage, power consumption, Bitcoins mined, average Bitcoin price, and the contribution margin. One of the most important records to keep is incident logs. Stuff that should be recorded include the times backup power needs to kick in, connectivity disruptions, mining rig failures, other equipment failures, circuit overload, perimeter breach, temperature or humidity threshold exceeded, etc. Keeping track of incident is a good way to pinpoint the root cause of your facility's downtime, which means that you can effectively pinpoint what should be fixed. Speaking of downtime, another good metric is the percentage availability, which is calculated as the time that is offline divided by the total time that it should be running multiplied by 100. And this equals to your availability percentage. If this particular percentage is less than 95%, I would suggest you look at the incident log and see what can be improved for your mining operation. You should also keep track of the power consumed and the amount of Bitcoins that are mined during the given period. You should also take note of the average market price of the Bitcoin over that same period as well. With the power consumption, Bitcoins mined, and its average price, you can get what we call the contribution margin, which is the sales revenue of the Bitcoins minus any of the variable costs. In this case, it is the power that your operation consumes. Now, you can add other metrics to your liking, but what I just cover should be enough for you to start off in your mining farm operation. Congratulations, for you have completed this course. You have now learned the fundamental knowledge you need in building a Bitcoin mining farm. You also have the various considerations and requirements in building a Bitcoin mining farm, so that you can actually now talk with the contractors as well as other installers that you will be hiring to build a state-of-the-art Bitcoin mining farm. Lastly, you now know how to track various metrics and make sure that your mining farm is fully optimized so that you can get the profit margins that you need to succeed in your Bitcoin mining operation. So now, what are your next steps? Well, your next step should be actually figuring out how you can start your Bitcoin mining operation. As you can see right now, mining is getting harder and harder. So the earlier that you're in the game, the better you will be. The best thing to do is actually to partner up with other people so that you could pull your money together and start to plan on how to secure a site and building your Bitcoin mining farm, hiring the right contractors, and make sure that you are building a state-of-the-art Bitcoin mining farm so that you could maximize your earning opportunity. Now, my other recommendation for you is to sign up to my other courses. As you can see from my instructor profile, there are a lot of courses that range from topics on utility concepts in electrical engineering, to project estimation, to various maintenance in my RCM FMEA course, to various sustainability development concepts. Now, one course that I want to recommend for you is to check out my Construction Estimating Quantity Takeoff Fundamentals course. In there, I actually teach you practical concepts on how you can calculate the various construction estimation that you will be seeing quite possibly in your Bitcoin mining facility construction. Now, perfecting the craft on construction estimating would actually benefit you in this, because you will be hiring contractors and you will be constructing, whether or not you are securing your own site or you are actually building it from a brownfield already existing building. You are still going to hire contractors to build this for you. So in this case, it is good to actually know how the estimation project works to get a better idea on the ballpark cost it will be. Because for every single business operation, keeping track of the cost and proper estimating is the first step in ensuring your success. Now, I wish you good luck in your future Bitcoin mining operation, and I hope that I could see you in my other courses. Thank you.